Okay, so I have a show, and the only access to electrical power we have is two 20 amp 277 volt circuits that are usually used for plug in the wall kind of air conditioners. So we need access to that power in order to complete our show. And what are you doing? You're gonna be on the video. Go away. I can't do this with you. Go lay down. Thank you. So in order to complete our show, we have to have access to that power. So I purchased used on eBay these 5 kVA transformers. They're multi-tap input and output. So I can have 120 volts, 240, 208, and 277 as an input. And then as an output, let me see here. I can have 120, 240, or 240, 120. So with a center tap. And that's actually the one I'm going to be using. So I have L1420 twist locks here, and I have a 15 amp 2-pole Carling magnetic circuit breaker I'm going to use on the output. It was very challenging to get a nice circuit breaker like this that would work over 250 volts for the input. So I chose this one instead. So the Venue has this plug standard, which is really an odd duck, this straight blade 277 volt 20 amp. But I checked that, and I got that the last time I was at the Venue. So I got 2 of these plugs. The only manufacturer I could find to have them in black and white nylon was Pass and Seymour. I really don't like these plugs, but that was really the only choice I had. So my 277 comes in here, and it goes into the taps for the 277 input, and then my output is these 3 things. So I have one of the phases, the other the phase, and the center tap. You can see the center tap has 2 wires in it because that's how you get the center tap. If you were just going to have the 240 volt version, you would just connect these 2 together, and you wouldn't need to tie on for a neutral for center tap stuff. I think foreigners call that split phase for the way the United States does it. Anyway, so what I want to do is just set up one of these. Go lay down, sweetie. And just wire it up really quick. So I have my incoming ground, and I have a spade with those tabs on it that I like, and I'm going to hook that on the screw. But these devices are also taking under tab wiring, so you can put the stripped wire under the tab without any connectors. But because I have the ground of the transformer and the ground of the device, I'm gonna do the ground of the transformer under the tab, and then use this hooked eye for on top of the screw to make the ground connection. So I'm just gonna do some of this here, and you can follow along if you want. So this is our neutral, or our center tap. So we'll have 120 volts from phase to neutral on these. And then our output from the transformer is going to go into the line of the circuit breaker. I can look at the circuit breaker and tell that it's oriented this way, so line is on this side and the load is on this side. But just to make sure, it's always worth checking that you have continuity this way and not this way. Because if you put it incorrectly, you'll be shorting out the transformer with the circuit. So make sure anytime you hook up a device like that, that you don't have that problem. These spades fit really tight, but if they did not fit really tight, I would give them a little squeeze. Because situations like this, devices can be prone to vibration, and you don't want these things falling off of these terminals after you've put it into service. So I'm gonna make up jumpers to go from the load side of our circuit breaker to the inputs of the two phases of our receptacle here. I know you want to go inside, but she doesn't want you inside. So you're stuck out here with me. And you're famous now, because you're on the video. You're very cute. Yes. Oh, you're jumping on my back. Oh, that's very nice. Yeah, I love you too. Yeah. What do you think? Should I have used 12 gauge for this? Maybe. But I had 10 gauge, so that's why I used it. I know I didn't need 10 gauge. You're my cutest cat. I hope you guys like cats. This is a little bit much. Okay, so I have these connectors that you should recognize, but I have been cutting off the yellow insulation for this application because I want to heat shrink the entire connection. Not to keep it attached, but just to keep it covered. And these aren't covered spades. You can get covered spades, and I actually think I have some, but I'm going for the heat shrink look. So if you're going to crimp something like this, these connectors have a slot in them. And if you have a crimper that has a little detent that's going to push into the slot, you want to make sure you put that opposite the slot. Because if you pinch in one side of the slot, that's not it. So put the dent on the back side, not the front side. Why don't you go lay down? I know. So recently on eBay, I needed another heat gun. And so I bought this master heat gun, but I was able to find this one like from the 80s. I'll call it an antique. It has a wood handle and this really raucous switch cover here. And it's all this like baked on crinkle paint. And it came with a receipt from the 80s in the box. And it was very, very fun to get. So I've been very happy with that. I think this is too short. Going to have to get some more. So I've been just recycling stuff like this. And so that's why I'm not using 12 gauge for this. It's just that I have this laying around and the cord is, I guess it's reasonable. It had some damaged spots on it, but I often get a lot of things like this where there will be 3-foot pieces of SO or SEOW cable, and it's just really hard to use sometimes. If you have 30 pieces of cable that are 2 feet long. I stripped too much. So I'll knock off another 2 millimeter. Okay. So you want to make sure that you flush out at the back. You don't gauche up any of the individual strands by having them pile up on the outside. I really hate that. And then your penetration into the connector is minimal so that it doesn't interfere with the spade. So I'm phasing this black and red just in case somebody besides me ever opens this thing up, but it's not strictly necessary for the way this works. Oops. I guess I forgot I was shrink wrapping the entire terminal. That's sad. Well, this side will be shrink wrapped and this side won't be. So if anybody asks, we'll just tell them that it's all part of the design. I won't tell them that I forgot. Nobody's coming down here and shrink wrapping these terminals on the side of this device, so I suppose it's probably okay. At least it's half and half. Again, I'm going to be really careful as I slip this into the device to not gauche up any of the wire tips. I really hate it when the little individual strands are piled up on the outside of wherever they're supposed to be. Okay, so I think that's it. That should be pretty simple looking. Let me take these little holding screws out that have been helping me here. So this is going to go flip up like this and then go down inside here. We can tighten up these connectors now. So this transformer happened to have a knockout on it, and I just knocked out the whole knockout because it was very close to the diameter of this device. And if you could notice, I also added some handles to this thing because it's essentially a steel box filled with a steel core wrapped with copper, filled with sand, and then epoxy encased. So it is very, very dense, i.e. very heavy to carry. and it has almost nowhere that you can grab it. So I put these handles on there so that two people can pick it up, walk around with it. This cord had a little bit of damage on it, just to the outer jacket. So I heat shrinked it nice, and so this is our L1420. So it's ground, neutral, and then 2 hots. So from any hot to neutral will be 120, and from either phase, or across both phases rather, will be 240. And that's the transformer project. And sneak this in here. I may need to adjust it with the hammer. Bend that out a little bit. These came in a UPS delivery, and the box was almost completely round and destroyed. It sort of looked like the box from Ace Ventura. So there'll be some more adjusting to get these on there. But our circuit breaker is here, so it pops out if it gets overloaded. And it's a 5 kVA transformer. So our input is 20 amps, 277 again, but we're only going to use 80% of that. So 80% of that input potential gives us really close to 15 amps, 14 and a lot. So very close to 15 amps per phase available. And so we're going to use the 2 phases with a L1420 extension and then a breakout, like a little fan that breaks out to single 515 or Edison connectors. And we're going to use that to power the equipment we have to run. So I have 2 of these, and I'm going to set them both up exactly the same. And we're going to go to the show, and we're going to power the show from these air conditioning units. So I hope that was interesting, and I hope you learned something. And, you know, I'll be making more stuff. I've been working on road cases, and I think I'm going to make a road case video here coming up, because I have a lot of road case stuff going on in the shop right now. And, you know, I think road cases are really important, and I think that everybody should, you know about road cases. Don't knock the camera over. Yes, hi. Okay, so here's a sneak peek of the road cases. So these are the cases I've been building. Got a couple different sizes, some really tall ones over there on the left. And they're only partially constructed right now. All their panel has been cut and all the extrusion for the double corner installed, but they're just blank half shells right now. So I gotta build carts for them and get them put together with lid seal and handles and latches and hinges. So that'll be fun. I'll have a video on that. Thanks, bye-bye.